Estimators are often overly optimistic. Three-point estimation, in particular PERT, corrects for that by blending optimistic, pessimistic, and most likely values into a weighted average that better reflects reality. I'm Cornelius Fichtner, and you are watching a PrepCast Exam Essentials lesson in which I'll show you exactly how PERT works using two examples taken straight from my PMP training course at pmprepcast.com. We start by looking at three-point estimations. Here we go, and I'm even wearing the same shirt. Three-point estimating is a simple but very useful approach to estimating the time or cost of work items. It's also useful here in risk analysis, where it allows us and our known risks to be quantified and built into the project budget. In addition, this helps the Monte Carlo simulation, which we just saw, to generate a statistical analysis of the probability of completing the project under budget or within schedule. And it is called three-point estimation because of the 3 points that it measures and uses to calculate a result. It uses the optimistic best case estimate, for example, the lowest cost or the shortest duration, and then the most likely estimate, as well as the pessimistic, the worst case scenario, that would be the highest cost, the longest time that an activity may take to complete. We project managers can use available information from comparable projects or subject matter experts to create these estimates. So three-point estimates can be done in two ways. First, there is the triangular distribution model, which, as the name suggests, calculates a simple average out of three numbers, out of these three numbers that we have here. Put in a simple format, the equation looks like this. You take the optimistic estimate plus the most likely estimate plus the pessimistic estimate, add it all together, and you divide it by 3. That's why it's a triangle, right? A, B, C together divided by 3. And then the second one, that is the beta distribution technique. Here, the popular formula that we all use is called PERT, the Program Evaluation and Review Technique. This uses a weighted average, not just a simple average, to determine the mean of the 3 estimated values that we have here, plus the pessimistic estimate. Here's the formula. Notice how more weight is given to the most likely scenario. Optimistic plus 4 times most likely plus pessimistic, and then divided by 6. All right, this makes sense because 4 times most likely, it's the most likely, right? See, we want to give that the highest weight. If plotted against the chart, this beta distribution will eventually result in a more uniform bell-shaped curve, which we call the normal distribution. So much for the theory on how to calculate triangular and beta distribution from my PrepCast lesson on risk. Let's move on to an example. And since these type of estimates, they help you determine how long a task will take in order to develop a schedule, well, the example comes from the lesson on schedule development. Here it is, and I'm still wearing the same shirt, but I'll have to undo this button here. We have talked so much about entering data into the project schedule, which, as we know, is at first always based on estimates. But how do we actually get to a solid estimate? Of course, they are just assumptions, and no one can really predict the future. But we can definitely see to making our assumptions a bit more stable and correct. One way to do just that is to look at how long something could take at its best, worst, and most likely scenario, and then calculate the average of these 3 values. This is known as the triangular distribution. In triangular distribution, we need to find the simple average of 3 estimates to get expected duration. This is called triangular because it's a simple average of our 3 points. To calculate the effort, add up our optimistic estimate, the most likely estimate, and our pessimistic estimate, and divide the results by 3. For example, we add 28 minutes for our pessimistic estimate, 13 minutes for our most likely estimate, and 10 minutes for our optimistic estimate. The expected duration or effort comes out to be 17 minutes. Looking at this graph here, I should point out the pie chart here is not meant to show different sizes for different estimates, but to show an estimate of effort divided by 3. In other words, the triangular distribution assumes that all 3 estimates weigh equally. But when they don't weigh equally, another way to calculate weighted average value can be used, called the PERT, or Program Evaluation and Review Technique. Here in this technique, the most likely estimate is multiplied by a factor of 4. So in essence, we pretend to divide our pie into 6 slices instead of 3. We then assign 1 slice to the optimistic, 1 slice to the pessimistic, and 4 slices to the most likely estimate. That is exactly what we do with the beta distribution estimate. We weigh or assign more importance to the most likely estimate. To calculate the effort, we take 4 times our most likely estimate, add our optimistic estimate and our pessimistic estimate, and then we divide the sum by 6. Plugging in the same numbers as before, in this case here, we get an effort of 8.5 minutes. The premise, the assumption here is that our estimators, they're simply going to be overly optimistic. The weighted average gives us an estimate of effort that is more balanced and statistically more likely to be accurate. Let's see how the math works in this using different estimates. In this table, we've plugged in other numbers to see the effect. In the middle of the table, we see both triangular and beta distribution, where estimated time durations came out to be 60 hours. Let's say we had an external optimist on our team. One estimate she provides says could take as little as 30 hours, another even less at 15 hours. We can see that the triangular distribution is more affected by that lower number, whereas based on beta distribution, the duration estimate stays closer to the most likely estimate of 60 hours. But what if we have a pessimistic estimator? Overall, our estimate numbers now are larger, but again, our duration estimate based on the beta distribution remain closer to the 60 hours, which are our most likely estimate. The wider the range between pessimistic and optimistic value gets, the more statistically significant it is to use the beta distribution formula. And that's it for our PrepCast Exam Essentials lesson on 3-point estimation, in particular triangular distribution and PERT, also known as beta distribution. Until next time.